And then I have to read your science textbook. Okay, so today and on Monday, we're basically going to be going through the review problems that are posted on Canvas. I'm also going to send out an email. Matt Katz is going to give a review on Sunday. I'm going to send out an email for the Zoom link. It's going to be from 1 until 4. So if you want, you can also go to that. Okay, guys. So let's continue with problem 3. So problem 3 asks the following. Show that these two lines, 3 plus t, whatever, and the second line intersect. So let's do that. So the first line is given in terms of R1 of t is equal to 3 plus t, 4 minus 2t, and 1 plus t. And R2, guys, please write down, thank you, is equal to 2 minus 3t, 1 plus t, and 2 minus t. So the first thing that we want to do is we want to set the x coordinates to be equal. So let's say x1 of t. And now you just need to switch the variable for the second one, just because that they might intersect, but the t's won't be the same. So maybe there's some s and t where these two, where this coordinate intersects. And from here we get, and this is problem 3. So from here we get 3 plus t is equal to 2 minus 3s. And then we want to set the y coordinates to be equal. So that's y2 of t is equal to y2 of s. And from here we get 4 minus 2t is equal to 1 plus s. So we want to now get rid of one of the variables, and we start by just setting the first two coordinates equal and then seeing if the third coordinate will be equal when those are equal. So if you multiply this part and you add it to this part, what we're going to get is 3 times 2 is 6 plus 4 is 10. And the t's cancel is going to be equal to 4 plus 1, which is 5. And then minus 6 plus s, which is negative 5s. And so this tells us that s is going to be equal to negative 1. Any questions so far? Okay, so once we get our s, we can plug it back into, let's say, this equation over here. So we put in the negative 1 for the s, and we get that 3 plus t is equal to 2 plus 3. So this tells us that t is equal to 2. And that's our t. So now that we know s and t, what we can do is we can plug them both into the third coordinate, the z coordinate. So that would be this part over here. And instead of t, of course, we have s right now. So what happens if you plug in 2 into this t over here? Well, we get 1 plus 2, which is equal to 3. What happens if we plug in negative 1 into this t, right? Because for the R2, we changed all of that to s. we get 2 plus 1, which is equal to 3. So they are equal, and that means that all 3 coordinates are going to be equal, which tells us that these lines intersect. Now we can also find the point of intersection. And that point will be, well, you plug in, let's say, your t into your first coordinate, and you get 5. You plug it into your second coordinate, you get 0. You plug it into your third coordinate, and you get 3. So the point of intersection is this point over here. Any questions about this? Yeah.
Could you real quick how you did the S, how you got S equals -1, just like the for that?
Yeah, so you take these two equations that you get from setting the x coordinate equal and the y coordinate equal. You change this t to s for the second one.
Yeah.
And then you take this and you multiply it by 2 and you add it to this. So 6 over here, 4, get 10. T minus 2t, because you're adding it, the t's disappear. This 2, you multiply it by 2 and you add it to 1, you get 5. And this -3, you multiply by 2, you get -6, and then you add it to this s and you get -5s. So just how the way you solve for 2 variables with 2 equations, that's basically how you do it. Okay, so now the second part of the question says find the acute angle of their intersection. So if 2 lines intersect and you want to know their angle of intersection, so here are your lines, let's say R1 of t and R2 of t. Well, all you really need is the vectors that form these lines. So let's say V1 and V2. And then you use the cosine formula to find the angles between these lines. Okay, so what is V1? So V1, if you go to the equations, is going to be 1, -2, and 1. And V2 is going to be -3, 1, and -1, right? Just reading it out from the coefficients over here in the equations. These coefficients, you can get your V1 and your V2. And then you can take the, so we know that the angle, and we don't know if this is the acute angle or not, but we will see how to tell in a second. But we get that the angle between these 2 vectors is going to be cosine inverse of V1 dotted with V2 over the magnitude of V1 times the magnitude of V2, which is going to be cosine inverse of 1 times -3, so -3 minus 2, which is -5 minus 1, so -6, over the magnitudes are going to be 1 plus 4 plus 1, which is the square root of 6, and 9 plus 1 plus 1, which is the square root of 11. Okay, and so this is cosine inverse of -6 over the square root of 66. But there is a negative here, and we know that cosine only becomes negative. Cosine represents the x-axis. So it only becomes negative when the angle of something like this, which is not acute, right? So this is when cosine, which is the projection onto the x-axis over here, that's the only time that this thing is going to be negative, right? So the angle over here is not going to be the acute one. We can just then look at this angle over here, which would be pi because we want the acute angle, so pi minus the angle that we just found, cosine inverse of -6 over the square root of 66, and that will be our answer. Or another way to think about it is by considering a certain symmetrical property of cosine. Well, fine, this is fine. We can leave it like this. Any questions about this? Yeah. Yeah, if it's negative, you know that you just found the obtuse angle, so you just subtract pi from it. If it says acute, if not, then you just want the angle. Yeah, but you're never going to get the angle. Let's say you're never going to get this angle like this. That's not going to happen. Yeah. Any other questions? Okay. Okay, so the next part is find the equation of the line, which also goes to the point of intersection and is perpendicular to the other two lines. So to do this, we just need to find the vector of this line. Well, if we're given two vectors, v1, which is 1, -2, and 1, and v2, which is -3, 1, and -1, we need a third angle in order to find the new line. And if it is perpendicular to both lines, it is perpendicular to both vectors. And so it will be, let's say, v, which is going to be v1 cross v2, which is going to be I, j, k. Of our v1, which is 1, -2, 1, -3, 1, -1. So finding the cross product. Okay, I'm going to leave the rest up to you, right? You find the cross product, that gives you v. And then for your third line, so then your R3, which is the line perpendicular to both of these lines, it's going to be our initial point, which is of intersection, which is the point 5, 0, 3, right? So you have some point where these lines intersect. You want this line to go through that point of intersection. So that's the point 5, 0, 3 plus this v vector that we found here times t. Okay, so all you really need to do to finish this problem is take the cross product, and you can look at the solution manual and see if you got the right answer. Any questions about this? Yes?
How do you get the vectors again? Like, if you plug in.
You don't plug in anything. So you go to the equations of your lines, and the vectors come from the coefficients in front of the t. So you see 1, -2, 1. That gives you your first vector. -3, 1, -1 gives you your second vector, just because of how the equations of the formula for the equation of a line looks. Yeah.
Can you go over the last part, or t is equal to I get the cross product of stuff is TV?
Oh, this v is just the v that you, right? So they're asking you here, you have two lines, and they're asking you to find the line perpendicular to both. We can think about it looking something like this, that goes through the point of intersection. So you need to find a vector representing this line, a vector v, and you get that vector by taking the cross product of these two vectors, and then you put that here. That's the,
Oh, so that's just the answer of the cross product.
yeah, so you just take your v and you put it here, and then this is your point of intersection, which is that point right over there.
Yeah, I got it.
Okay, any other questions? Okay. So the fourth question says find the equation of the plane which goes through these points. and find the area of the triangle formed from these points. Okay. So we have one point. Okay, so we have the first point is going to be 5, 1, 0, 5, 1, 0. The second point is going to be 1, 1, negative 1, 1, 1, negative 1, and the third point is going to be negative 1, 0, negative 2, negative 1, 0, negative 2. You need to, so if you're finding a plane that goes through these points, here are your 3 points. What we need to do, so this is P1, P2, and P3, is we need to form a vector from P1 to P2, and then form another vector from P1 to, let's say 2, okay, and P3. And these are going to be, let's call them V1 and V2. You then take the cross product between them to find the normal vector, and then you use the equation of your line to finish the problem. So let's figure out what V1 is. So V1 is the vector going from P1 to P2, and it's going to be second. Oh. I guess I didn't do problem 4. And that's probably because that I guess I shouldn't actually spend that much time on this problem. So the rest of it, you should be able to do. Find these vectors, find the normal vector, and then find the equation of the plane. All right, I actually did this problem. So let's do it then. Okay, so the vector V1 is going to be the vector -4, 1 minus 1, which is 0, and -1 minus 0, which is -1. And the vector V2 is going to be the vector going from P1 to P3. That's going to be the vector -1 minus 5, which is -6, 0 minus 1, which is -1, and -2. Okay, so these are your vectors. You then just get your normal vector. So your normal vector is going to be the cross product of these two. So it's going to be P1 V1 cross V2. Okay, so that's going to be I, J, K of -4, 0, -1, -6, -1, and 2. So I'm going to leave it to you to find this normal vector and then complete the problem by finding the equation of the plane. I'm also, once you have your normal vector, in order to solve the second part of the problem, find the area of the triangle formed by these points. Well, if you remember, you just take your V1 cross V2 and you find its magnitude and you divide that by 2, and that will be the area of the triangle ABC. I changed the points ABC to P1, P2, and P3, but same thing. And you can then check to see that you got the right answer. Any questions about this problem? So yeah, I don't want to focus too much on it because it is fairly straightforward. That's the problem 5. Any questions? Okay, so problem 5 says find an equation for the line of intersection between these two planes and list 4 points which lie on this line. So again, we need to use the cross product. If you have these two planes, here is one, and here is another plane. Here is the line of intersection between them, or maybe in order to find the equation of this line, we need to find the vector v that forms this line. And what we can do, of course, is we can go to the planes and find the normal vector of the first plane. So maybe that's this vector over here, n1, and then find the normal vector of the second plane, and that would be this vector over here, n2. Take their cross product, and that will give us v. So let's do that. So we know that v is equal to the cross product of n1 cross n2, which is going to be equal to, so our n1, if you look at your planes and you read out the equations for the normal vector, you're going to get 1, 3, and -1. And then our n2 is going to give you a 2, -1, and 2. So you put this in I, j, k, 1, 3, -1, 2, -1, and 2. And so then this gets you to, and I believe in the answer, these two vectors were flipped. So you just get the negative for the answer of the plane, but it's the same plane, just with, let's say, the opposite normal vector or something like that. But this is going to get you the vector. So in the I component, you have 3 times 2, which is 6, -1. So that's going to be 5. In the J component, you're going to have negative of 2 minus 2, which is going to be 4, but then you have -4. And in the K component, you're going to get -1 minus 6, which is -7. So this is your vector v. Now you only need to find a point on the two planes. So if we go to our two planes, here are the equations. So the point 1, 1, 2. So if you put 1 in here, 1 in here, you get 4 minus 2 is 2. So it works here, 1, 1, 2. And if you plug that into here, you get 2 minus 1, which is 1, plus 2 times 2. So that's 4 plus 1, which is 5. So it works for the second plane as well. Yes?
Did you just like guess for that point or did you solve?
I personally prefer to guess, and generally it won't be like you won't need fractions or anything like that. So yeah, just try to guess some try first with zeros. If it doesn't work, try some other points. If that doesn't work, you can try to solve for it, but generally you won't have to. And yes. Sorry, what? We're guessing a point that lies in both planes. So in order to find the line of intersection, you need to find the vector v, which is fairly easy to find. You just take the cross product, and you need to find a point that is on both of the planes. So you can start at some actual point which lies in both. So in order to guess that point, You go to the equations of your plane and you try to guess a point which satisfies both equations. And that's kind of a guessing game. So like I said, start with like putting 0 in some of the coordinates, 1 and whatever. It generally won't be anything complicated. So this 1, 1, 2 is not that difficult to guess. Any other questions? Okay, so once we get this point, 1, 1, 2, we can say that our line R1 of t is going to be starting at the point 1, 1, 2, and then adding to that t of our vector v, which is 5, -4, and -7. Any questions about this? So then they tell us list 4 points which lie in this line, which, okay, not a great question, but you can choose, let's say, t equal to 0, plug it in, that will give you a point. So that's 1. T equal to 1, and another point, t equal to -1 will give you a third point, and t equal to 2 will give you a fourth point. So I'm not going to do this, but that's basically what you would end up doing, and that gives you 4 points on this line. Any questions about this? Okay, so let's go on to the next problem. So problem 6 says, find an equation of the plane which is parallel to this plane and goes through the origin. That's for A. So the plane is 3x plus y minus 4, or whatever. 3x plus y minus 4z is equal to 5. Well, if for problem A, if your plane is parallel to this one but goes through the origin, then you just plug in 0, 0, 0 for x, y, and z, and that should tell you what your d is. And of course, if you're going through the origin, it will be 0. So the plane that answers this problem is 3x plus y minus 4z is equal to 0. So that's how you solve problem A. Then for problem B, they ask you calculate the distance between these two planes. So I'm going to do it in 2 different ways. One of them we did not talk in class, but if you want to find the distance between 2 planes, there is a formula for that. You have one normal vector for both planes. So the normal vector for both planes is going to be 3, 1, and -4. And then you have your d component and the formula to find the distance between these 2 planes. And we'll see that you can also use projections to solve this problem, and projections work for finding the distance between a line on a plane or a point on a plane. So it's more general. But in this case, okay, I'll mention this in the end, but in this case, you can use the formula to find the distance between these 2 planes. So let's call the first plane P1. And P2. So the distance between P1 and P2 is going to be D1. So those are these constants over here, minus D2, the absolute value, over the magnitude of the normal vector. And that's going to be, in our case, 5 over the square root of 9 plus 1, which is 10, plus 16, which is 26. So 5 over the square root of 26, and that will be your answer. Now, of course, we can also use projections. So let me go to another. Any questions so far? Yes. You take the absolute value.
Also for that curve for the n, it's going to be 4 instead of 4. That's the equation 1, minus 4z.
Yeah, but you take the square of that
Oh,
for the Pythagorean theorem. Square root, each component squared.
okay.
Any other questions? Yes?
So like I'm confused on example like homework 7, number B.
Oh, wait, let's finish 6 and I'll get to number 7, okay? Okay, so the second method is here are your planes, plane 1 and plane 2. You find the point on plane 1, you find a point on plane 2, you create a vector between them, you take the normal vector and you project this vector onto this vector, find the component of that projection, and that will give you the distance. Now this, by the way, this method also works if you have a plane and a point, and you're trying to find the distance between this plane and this point. But another thing that you can do is you can create a plane parallel to this plane at this point, right? And all you need to do is same normal vector, just find D, and then use the formula for the distance between planes. So that works here too. If you were trying to find the distance between a plane and a point, you can either use projections, or you can find a plane that goes through that point that is parallel to your original plane, and then use the formula for finding the distance between two planes. Okay, going with the projection method, our plane was 3x plus y minus 4z is equal to 5, and 3x plus y minus 4z is equal to 0. So for example, just to see the connection between these two, if they ask you find the distance between this plane and the origin, so the distance between this plane over here and the point 0, 0, 0, well, you can find this plane that goes through the origin and is parallel to this plane, and then use the distance formula between planes. But another thing, again, that you can do is, let's find 2 points on these planes. So on the second plane, the easy point to find is the point 0, 0, 0, clearly lies in the second plane. And on the first plane, the point 1 and 2, so 1, 2, 0, if you plug that into your first plane, you get 3 plus 2 is equal to 5. So we have our 2 points. Now we need to make, so let's call this P, and let's call this Q. So we need to find this vector. So this is the point P, this is the point Q. We need to find the vector which goes from P to Q. And it's going to be the vector 0 minus 1, which is -1, 0 minus 2, which is -2, and 0. And then our normal vector, well, we already saw that before. Our normal vector is going to be the vector 3, 1, -4. So the component of the projection between V and N is going to be the dot product V dot N over the magnitude of N, which is going to be -1 times 3 is -3. 1 times -2 is -2. So this is -5, right? 0 times -4 is 0 over the magnitude of N, which is the square root of 26. We already did that. Now this is the component, and it just has a negative here, just to say which side the vector is going in. But if you want to find the distance, you take the absolute value of this. So you take the absolute value of your component, and that gives you 5 over the square root of 26. So same answer. Any questions about this? Yes?
For the distance formula, is it the magnitude of which normal vector?
Same normal vector, because they're parallel planes.
Oh.
Any other questions? Okay. Problem 7. So problem 7 says let U be this, and VWK calculate the area of the parallelogram generated by U and V. So let me. Okay, so U over here is equal to 1, 5, and 2, and V is equal to 3, 0, and -1. The area, so here is your parallelogram, U and V. The area of this parallelogram we have seen is the magnitude of U cross V. So what is U cross V? U cross V is equal to IJK 1, 5, 2, 3, 0, -1, which is going to be equal to okay, so in the I component, we get 1 times -1, which is -1 minus 6. Oh, sorry, I'm reading the wrong thing. Okay, so it's 5 times -1, which is just -5, times 0 minus 2. Okay, the J component is going to be negative of 1 times -1, which is, so that's the negative 1 times -1, which is -1 minus 6. So minus 7. So that's going to be a positive 7. And then for the K component, we are going to get 0 minus 15. So -15. In order to find the magnitude then, so the magnitude of this is going to be, so the magnitude of U cross V is going to be the square root of 25 plus 49 plus 225, which is going to be the square root of 299. Any questions about this? Okay, the second part of the question says, calculate the volume of the parallelepiped generated by U, V, and W. So now, instead of having a parallelogram like this, you have 3 vectors. So your 3 vectors now are going to be U, V, and W. So that's something like this. And we said that in order to calculate the area of this parallelepiped, you take the determinant of your 3 vectors. So U here, V here, W here. So what is that going to be? So that's going to be the determinant of 1, 5, and 2, 3, 0, and -1, 0, 4, and 1. And you can try to calculate this determinant yourself. Again, remember, instead of IJK, you put 1, 5, and 2, right? So it's going to be 1 times the determinant of 0, -1, 4, 1, minus 5, and so on and so forth. So please try to do this. And the answer is going to be 13. Any questions about this? Yes.
Does it matter what order you do U, V, W?
No, because, okay, again, I forgot, but there is an area is always defined with absolute value. So there's an absolute value. Yes. What do you mean? You mean take the determinant for three, like, it's only if a parallelepiped question appears. That's the only case where you have to do this. Any other question? But it's the same as the regular cross product. So just instead of I, J, K, you just put the numbers where I, J, and K went. Okay. Any other questions? Okay, so that was number 7. Okay, number 8, the points 2, 5, 8, and -4, 3, 0 lie on opposite ends of the diameter of the sphere. Find the equation of the sphere. So this question is asking us, here's your sphere. You have 2 points. Then you have a sphere. I believe in the 6th problem in the homework 3, you have similar problems. You're given points and you need to find curves between them. I would suggest that you remember to put the t, how far this goes from, like from 0 to pi or something like that, just to make sure. You can't just write the equation, but over here you only need to put the equation. So your points are P1 is equal to 2, 5, and 8. And P2 is equal to -4, 3, and 0. So those are these 2 points over here. Let's say P1 and P2. So the first thing that we want to do is we want to find the radius of the sphere in order to be able to use it in our equation. So that's just the distance between P1 and P2. That will give us the diameter, and then we divide that by 2 in order to find the radius. So what is the distance between P1 and P2? Well, that's the square root of -4 minus 2, which is -6 squared. So that is 36, plus 3 minus 5, which is -2 squared. So that is 4, plus 0 minus 8 squared, which is 64. And that will be the square root of 104. So that's going to be the diameter. We now take this and we divide it by 2 in order to find our radius. So our radius, let's call it R, is going to be the diameter between P1 and P2 over 2, which is going to be 104 over 2. We can put the 2 inside and we're going to get 104 over 4, which is the square root of 26. So now we know our radius. So our radius is the square root of 26. The second piece that we need is we need the center of this sphere. And in order to find the center of the sphere, what we can do is we can find the line that goes between these 2 points using the vector going from P1 to P2. And if t is 1, well, if t is 0, we'll be at P1. If t is 1, we're going to be in P2. So when will we be at the center? When t is 1/2. So we will just plug in t equal to 1/2, get the center, and then we can find the equation of the sphere. So let's find the line between P1 and P2. So we need our vector v. So our vector v is going to be -6. 3 minus 5, which is -2, and -8. So now the line R1, or let's just do RT, between these 2 points is going to be starting at the point 2. We'll be starting at the point 2, 5, 8, and then you add to that t times -6, -2, and -8. And now the center of this sphere will be at R of 1/2, which is going to be 2, 5, 8 plus -3, -1, and -4, which is going to be -1, -4, and -4. So this is going to be the, 4 and 4. So this is going to be the center of our sphere, is this point over here. So now the equation of the sphere is then going to be x plus 1 squared plus y minus 4 squared plus z minus 4 squared is equal, and the radius was the square root of 26, so you just put 26. Any questions about how to do this problem? Yeah? Oh, no. Any questions? Okay, so let's do the next problem. So problem 9 says find the equation of the sphere which is centered at 1, 2, 3 and which is tangent to the x, y plane. So this is the point P1 is equal to 1, 2, 3. Now we want to find the distance between here and the x, y plane. So the x, y plane, that happens down here when we set z equal to 0. So that's the distance between here, and the shortest distance between this point and the x, y plane will be another point P2, which is going to be equal to 1, 2, 0. Now, again, we want to find the distance between these points, and the distance between P1 and P2 is just going to be the square root. 1 minus 1 is 0, 2 minus 2 is 0. So 3 squared, which is going to be 3. So that's the distance between them. And then P1 is the center. So the equation of the sphere is going to be x minus 1 squared plus y minus 2 squared plus z minus 3 squared is equal to 3. Or sorry, 9. Yeah, because the radius is 3 because it's from this point, and that's the center of the sphere. So it's going to be 9. Okay, in order to do, any questions about this? In order to do the second part of the problem, find the equation of the sphere which is centered at 1, 2, 3, and which is tangent to the plane z, -2y, and 4. So in order to do this, we have our point. We have our plane, and this is the plane -2y plus z is equal to 4. Is equal to 4, and we have our point, and the point is 1, 2, 3, 1, 2, and 3. So we need to find the distance between this plane and this point, which you can do again using projections. And then that will tell you the radius, and then you put this as the center, and that will give you your answer. So try doing this. And on Monday, we are going to continue with problem 10. Yes. Well, I think they sent everyone emails about all the test times and the place where the test will take place, but I'll try to put together an email and send it out, okay? Yes.